Hello everyone. Today we are going to see the palindrome linked list. Okay, now this is the most easy question that you will find with the topic of linked list. Okay, first we should see what is the problem given. Okay, now first the only the head will be given. Okay, head will be like a pointer pointing to the starting of the linked list. Okay, and we have to check if it's a palindrome or not, and we have to return the boolean value. Okay, boolean value we have to return. Now the problem is like we if we are going to check like palindrome, so from traversing from the both side. Okay, that should give a equal, it should be equal, like 1 to 1. If we are reversing that, then it again it's 1 to 1, that says equal. Okay, so that's palindrome. And the problem with the linked list is that we can't keep a two pointer, like at the starting one pointer and the end one pointer, like we did in the array. But the checking with the linked list, it becomes difficult. With the array it's easy. We can't keep and the point that we can't keep the pointer at the end, because we can't traverse in the backward direction, because all the pointers are pointing towards forward. Okay, so that's the problem. And yeah, we are going to solve this. You can see the second example also, like 1 2, that's not equal to 2 1. Okay, it's not equal, so it's returning false, and here it's true. Okay, so what the easiest approach to solve this problem is like to store this whole content like 1 to 1 in the separate array of size 4 with a 1 to 1 value, and we'll keep uh, two pointers. Okay, something like I and j, and we'll move one forward, and we'll check if all the contents are equal, and we'll check that till half of the given array. Okay, so that way we can check from our palindrome. Okay, so that is the brute force approach. Okay, now we should proceed with that approach. Okay, so first of all, I declare one array. Okay, declare one array, no in, and here we need the size. Okay, now here we need the size, so we'll move a pointer in whole of the linked list. Let it be cur. Okay, that we should be pointing to head, and we will move this whole of the pointer in the linked list till my current is not equal to null. Okay, and the current is equal to current next. Okay, current is equal to current dot next, and we'll count is equal to count plus plus. Okay, and here we have to like count. So first I think count should be 1. Okay, because first counter is here. Okay, and again second, third, fourth, it will increase. So I think first should be 1, and since head can also be null, and if head, okay, if head is equal to null. Okay, or means head dot next. Okay, head dot next means only one node is there, only one node is there. Okay, then also head dot next, actually the head dot next, and you have to return true, because only one value, it's palindrome only. Okay, so you have immediately you'll return true. Okay, now if the count is greater than 1, so initially the count will set to 1. Okay, and then we'll proceed to count all the nodes that are present in the linked list, and this count we will use to initialize our array. Okay, count. Okay, now then again we will move. Okay, then for int I is equal to 0, I should be less than the count. Okay, and I should be plus plus. Okay, now here like count is 4. Okay, 0 1 2 3, it should move till 3 only, so 0 is to less than count. Okay, yeah, and here it should be no, current next is null. Okay, ARR of phi is equal to the current dot value, okay? Current dot value, and current is equal to current dot next, okay? But current, we have to again set it to the head, okay? Because we have already used once time, and we have already used, so again we have to point it, okay? Now it's okay. And yeah, the value has been set to the array, and then we'll point like two pointer, I is equal to 0 and j is equal to count minus 1, okay? And then we'll check if my I is less than j. Till my I is less than j, this whole loop will be running, okay? I will be here, j will be here at second position, okay? Now then it will run, but when I will come here and j will come here, then it should not run. So I'm just putting that condition as my while, okay? So if in any point ARR of I it's not equal to ARR of j, if any point it's not equal, then you have to immediately return false, okay? Immediately you have to return false, and if it's coming out means it has run successfully, and you have to return true, okay? Now I think everything is correct and we should check it. Okay, now what's the error? Okay, yeah, if head dot next is equal to none, okay? Now both should be boolean. It's like it's coming as a boolean over here, and only head dot next was there over here, so it will show it obviously. Now what is this error? Val is there, integer, current dot val, okay? Why it's showing an error over here? Okay, null pointer exception, okay. -1, okay. Expected is true, but it's returning false. Count -1, and it should run from 0, okay. So here the error is occurring, okay? It should be false only. It should be false. We have to check this condition, okay? Basically 0, j should be count -2, okay? Just check it. It should be 1. I is less than j, and E out of I is not equal to E out of j, then return false, okay? Okay, this I should be incremented and j should be decremented, okay? Here this was missing. This will fall into infinite loop, okay? Now also it's false, okay? You should check it again, okay? Instead of putting here -1, I'll put it here +1. Okay, now let's check it. Okay, now if I put it as a 0, okay. That has run successfully. Okay, now the counting, some problem was there. Like, first of all, I'll point it as a 0, okay, and then first node I'll point it as a 1, then second node, third node, further it was counting the null value also. That was it showing error. Okay, now since it has been successfully run, but it's not the optimal way of solving, because you're using much space and time as well. Okay, space of like 4 values it's we are using, so this is not the optimal way of solving it. So we'll see another approach. Now, without using any extra space, we'll go for just pointer approach and we'll try to check it. Okay, now what approach we'll see, what approach we'll be following is, like, first of all, we can see that this array linked list is equal in half of the way. Okay, equal to the half of the way we'll travel, and this equal. Okay, so we will separate this two, okay, from the middle. Okay, so first we have to find a middle value we have to find, and we have to break the connection. Then we will go for the reverse of the second half. Okay, we'll go for the reverse of the second half, and since it will be reversed, okay, this pointer will be pointing like this way, then we'll move 2 pointers for first head from the first half starting, and the second head from the second half starting, that will be from here, and we'll check for each of the node is equal or not, and then we'll move forward like we are doing in array. So and if it's equal, then we'll proceed. At any point it's not equal, then immediately we're going to return false. Okay, now let's see that approach, how we are going to do that. It's like, first like we have to middle value. Okay, first we have to find the middle value. List node middle. Okay, mid of the, okay, now middle value, okay, middle value of head. Okay, middle value of head, and then whenever we'll return receive this middle value, then we'll immediately push it to the reverse. Okay, of mid, and what we are passing for the reverse, we will pass mid. Okay, okay. First we have to write this function. Okay, this will be list node, it will return middle value of list node of head. Okay, and the next function that we are going to do is list node of Now for the middle value, we will use 2 pointer approach. Okay, one will be the slow pointer, one will be the fast pointer, that both will be pointing to the head. Okay, and fast pointer, that will be pointing to the head, and then we'll run a check. Okay, that should be fast should not be equal to null, and fast dot next, okay, also should not be equal to next, okay, should not be equal to null, okay, not next, okay. Okay, and then we will move the slope by 1 point, fast by 2 points, okay. Hope you are doing this approach, okay. Okay, this is just like finding the middle of the linked list, okay. Now ultimately we'll return this slope, okay, that will be the middle, okay. Now we'll come for the reverse part. We have to reverse this head, okay, and in which we are passing this mid, okay, this middle value we are passing, okay. So here we will take this node. We'll first take a current value that will be pointing to the head, and some previous value that will be pointing to the null, and one more in value, okay. Now we'll move this till my current is not equal to null, okay, and first of all we'll give this n value n2, and we'll give a value that will be the current next, okay. And current dot next, again it will be pointing to the previous, and previous will be moved one forward, okay. Previous will be equal to the current, and then the current will be equal to the n in which the value has been stored. Ultimately, after coming out of the loop, each value will be reversed, okay, and the previous will be pointing towards here. All the pointers will be reversed, okay, till here, okay, half of it, okay, we are pointing the middle, half of it, and this will be pointing towards the null, and the current value will be null, because here the condition will become false, then only it will come out of the loop, and ultimately we'll return the previous value, okay, because it's only the current head that is pointing. So yeah, from here we are getting like we have already and then over here we should set like a mid off, okay. Here it's mid off, okay, here it's mid off, and mid off here, after this mid off will be this value, okay, and this value should be pointing towards the null, okay, this value should be pointing towards the null. Mid off dot next should be equal to null, okay. So mid off dot next is equal to null, okay. Now list node of temp. Now again we will be moving two pointers, okay, one from here, another from here, okay, and we can reuse the pointer nodes in the different function, so we have to make use of, okay, reverse is pointing here, and the head, we should not lose it, so we will create a temporary node that will be pointing towards head, okay. See, head is already pointing towards the side, but we don't want to lose the head value, okay, so we will be like a temp1 we should take it, and the second reef is pointing towards this node, but after checking we don't have to use the linked list, so we can use this pointer only. So while my temp, only temp, it's okay. while my temp is not equal to null. Okay, while my temp is not equal to null, or rate is not equal to null, so what it will do is will check if my temp dot value it's not equal to brief dot value. If it's not equal, then it will return false. Okay, then it will return false. And if it's equal, and we have to move one forward. Okay, temp is equal next, and next. Okay, and if it's coming out of this successfully, then it's a palindrome and will return true. Okay, now 45 number line. Okay, breathe. Okay, if you'll put this AND operator, then I think it will be corrected. Now it's got accepted. Yeah, so this was about the palindrome linked list, and it's the most frequently asked interview question. In that, you have to give both the brute force approach as well as the optimized approach. So do practice it well. Okay, if you have any doubt, please put it in the comment section. Meet you in my next video. Till then, thank you.